So the next characteristics of chemical reaction is change of energy. It is also one of the characteristic of chemical reaction. Means energy gets changed in almost all the chemical reaction, and this energy is in change in which form? In the form of heat. Which energy? Heat energy is going to change during the chemical reaction. Okay, and here the change is going to simply indicates this heat energy either produce or what? Absorb. Okay, either the temperature gets increased. If the heat energy absorbed by something, so definitely its temperature get increased. Is it now? And if heat energy gets released, then what will happen? The temperature of the substance gets reduced. Understood now? So in these two ways, what happened? The chemical reactions takes place. In some of the chemical reactions, you observe that the heat energy is going to absorb. Okay, and in some of the chemical reactions, you will observe that the heat energy is going to evolve or produced. Clear? Understood? And on the basis of these two conditions, either absorption of heat energy or releasing of heat energy, the chemical reactions are categorized in two ways, in two groups. And the first one is endothermic reactions. What is the first one? Endothermic. Here the word endothermic indicates for what? The heat energy is produced or heat energy is absorbed. Heat energy is produced or heat energy absorbed. Endo word indicates for what? Endo. Heat energy is absorbed. Alright. So we can show it by the symbol how? Plus heat or minus heat? Plus heat. It's going to absorb, not produce. Get it? So minus heat. And the second one is exothermic reaction, and we can show it by plus heat. Here the heat is going to reduce. Okay, understood? And here the heat is going to absorb. Heat is going to absorb indicates for what, children? Heat is going to absorb indicates for what? Means when the two different substances are going to mix together. So simply by mixing together at normal temperature, the reaction will not occur. Get it? Why? Because they require heat energy. And when we will heat it on the flame, then that reaction will complete. Get it? So this shows that what? That chemical reaction requires the heat energy. So heat energy involve in it. Without heat energy, that reaction will not complete. Understood or not? You might have seen in chemistry labs when we are going to mix certain substances in test tube. After that, we heat it on the burner. Is it? Have you seen? We heat that mixture in the test tube on the burner. Is it now? Then that reaction gets complete. Then that reaction starts. So this shows that which kind of reaction? Endothermic. Get it? Understood? So we will discuss it with the help of some examples also. One by one. First we'll discuss about the endothermic reaction. And the example of endothermic reactions are carbon. C is the symbol of carbon. When the carbon is going to react with sulfur, S is the symbol of sulfur. Then the product will form CS2, and this is known as carbon sulfide. What is this? Carbon disulfide. Get it? And what will write also here, the heat is produced or involved. So we will show it minus heat. So in this chemical reaction, heat involved. It means that simply by mixing carbon and sulfur at room temperature, normal temperature, this reaction will not occur. This substance will not form. Product carbon disulfide will not form. How it will form? When we will heat that mixture of carbon and sulfur. Okay. When we heat it, then carbon disulfide will form. Get it? So heat is going to absorb. Heat is going to absorb, and we will show it by applying minus heat. Get it? And this is the example of which kind of reaction? Endothermic reaction. Okay? Now this reaction is not balanced, and for balancing it, we will write 2 here. Get it? Now, another example is there. N2. Yes, nitrogen. When nitrogen is going to react with oxygen. Okay, so N2 is the formula of nitrogen and O2 is the formula of oxygen, and when they both are going to react together, it will form a new product, that is NO. NO is what? Nitric oxide. Okay, so NO will form nitric oxide, and this will form in the form of gas. So how the gases are shown? By upward arrow. Okay, so nitric oxide will form when the reaction will take place between nitrogen and oxygen. Clear? But this gas will form not simply at room temperature. Okay, it requires the heat. So by heating nitrogen and oxygen, which gas is going to form? Nitric oxide gas is going to form, and this reaction absorbs the heat. Clear? So this is also one of the example of endothermic reaction. Clear to everyone? Okay. Now come to the next, the second one, exothermic reaction. Exothermic reactions are shown by plus C. So this indicates the heat is what? Involved or produced? Produced. So these reactions does not require the heat. Okay, simply by mixing the substances, the reaction will complete, and during the reaction, if we touch that test tube in which the reaction is going to occur, so we feel that the test tube gets heated. Get it? So it shows that during the reaction, heat is produced. Alright, that is why it's known as exothermic reaction. And the example of this reaction is with carbon. C is the symbol of carbon. With carbon is going to react with oxygen. So O2 is the formula of oxygen. Well, they both will react together. They form a gas. Which gas? Carbon dioxide. Yes. Carbon dioxide gas will form. Get it? And what also will produce? Heat will produce. Get it? Along with the formation of carbon dioxide gas, the test tube in which we have mixed these both substances, the test tube gets heated. So this shows that this is a what? Exothermic reaction, because heat is produced. Understood, children? Okay. Now, one more example. CaO. This is calcium oxide. Calcium oxide is going to react with water. H2O. Okay, H2O is the formula of water. And when they both will react together, a new product will form. And that product is calcium hydroxide, CaOH twice. CaOH whole twice. Get it? This is calcium hydroxide. And along with it, what will form? Heat will released. Heat will produced. Get it? So this is also the example of which reaction? Yes, exothermic reaction. Calcium oxide when mixed in water. So children, remember that today we have discussed in the starting that activity in which we have used the lime water to show the change of color by carbon dioxide. So actually that lime water is produced how? That lime water is produced with calcium oxide mixed in water. So what is going to produce? Lime water. This is lime water, that is calcium hydroxide. Okay, calcium hydroxide is what? Lime water. The common name is, general name is lime water, and the chemical name is calcium hydroxide. So at the same time, when this calcium hydroxide is going to form, the heat is also produced. So the container in which we have mixed water and calcium oxide, that container get heated, and you can feel it very clearly by touching it. Get it? And if you are going to do the same reaction in a test tube or beaker, so your test tube also gets heated. Get it now? So this shows that here the heat is going to produce, and that is why this reaction is categorized as exothermic reaction. Alright? Understood everyone? Thank you and have a nice day for today.